A locating pin may be only a few millimeters across, yet an entire fixture can inherit its position from that small contact surface. Once the locating diameter wears, chips, bends, or becomes part of an unintended electrical path, alignment error begins at the datum itself. Precision therefore starts much earlier than the machine controller. The different tip, shoulder, and shank geometries shown here are not decorative variations. A locating pin has to guide a feature into position, establish a repeatable reference, survive repeated contact, and release without damaging the interface. The ceramic material and the geometry have to perform as one locating system. The first requirement is a contact surface that does not quickly change size. Density stabilized zirconia used for precision components is typically in the 12 to 13 gigapascal Vickers hardness range, with a representative 3 Y-TZP reference grade around 1350. Hardness does not create accuracy by itself, but it slows abrasive change at the tip and locating diameter. A locator also sees edge contact, side loading, misfeeds, and occasional impact. Y-TZP addresses that problem through transformation toughening. Near a growing crack, stress can trigger a local tetragonal to monoclinic phase change that creates a compressive shielding zone around the crack tip. The reference range used here is about 900 to 1200 megapascals in flexural strength and 8 to 10 megapascal root meters in fracture toughness, depending on the exact grade and process. For resistance welding fixtures, the third property becomes especially important: electrical isolation. ISO 9312 specifically covers insulated pins used in resistance welding equipment, and welding guidance recommends an insulated location pin for projection welding of weld nuts. Dense Y-TZP grades have very high room temperature electrical resistivity, commonly above 10 to the 11th ohm centimeter. Resistivity changes with temperature, so the actual duty still has to be reviewed as a complete electrode and fixture system. Locating begins before the precision diameter makes full contact. A tapered, conical, or rounded lead-in helps a hole or nut enter the pin without striking a sharp cylindrical edge first. The lead-in guides the part toward the datum, but it should not be confused with the final locating surface. Its angle, radius, and transition have to match the way the workpiece approaches the fixture. The actual lateral reference is established where the mating feature contacts the locating diameter. That interface controls how much movement remains before clamping. Too much clearance reduces repeatability. Too little can create binding, over-constraint, or difficult release when temperature and contamination change. The correct fit is therefore a system decision involving the pin, the hole, the second locator, and the fixture datum scheme. The fixture side matters just as much as the workpiece side. A shoulder or flange can establish axial seating, while the retained shank transfers load into the holder. The mounting method must support the ceramic without introducing uncontrolled bending, hoop stress, or point loading. In practice, the best retention method depends on the pin geometry, impact level, replacement strategy, and the stiffness of the surrounding fixture. Positioning pins cover a much wider size range than the word pin might suggest. The dimensional examples for this zirconia family extend from roughly 4.9 to 55 mm in overall diameter and from about 17.7 to 55 mm in overall length. Those figures describe available examples, not a universal industry standard. The functional dimensions are the tip, locating diameter, shoulder, and mounting shank. Non-standard sizing starts from the mating geometry rather than from a single nominal diameter. The drawing should define the lead-in shape, working locating diameter, contact length, shoulder position, overall length, mounting interface, and any anti-rotation feature. Surface finish and edge condition also belong to that definition because the locator is a repeated contact component, not just a static spacer. In weld-nut projection welding, the locating pin passes through the nut or workpiece feature and establishes position relative to the electrode before force and current form the weld. The locator is placed inside an electrically active assembly, so insulation at that point helps keep the locating function separate from the intended welding current path. Every loading cycle rubs the mating feature across the tip and working diameter. A hard, polished zirconia surface helps slow geometric wear at those repeated contact zones. That matters because the pin is not merely holding the nut. Its working diameter is part of the dimensional reference that sets the position before welding. Automated loading also brings occasional side contact and imperfect approach. Zirconia is used when higher fracture toughness and impact tolerance are needed at the locator, although severe thermal shock conditions still require careful ceramic grade selection. At this scale, precision is not stored only in the controller. It is stored in the few square millimeters of ceramic that establish the datum every cycle.